All right, let's go ahead and take a look at 4.1, graphing. All right, so generally, by and large, people really struggle with this one. So we're going to look at this first one, and it says graph the point -4, 0 on this coordinate system. One thing to note is how coordinates are labeled. So for us, every coordinate ever will be given in this x, y format. And one way to really think about it is that coordinates are always listed in alphabetical order. So if you go through the alphabet, you got x, y, and then technically there's a third axis that we don't see, the one that's coming right at us, which is z, which would be, back here. But for us, we're just going to focus on x and y. And so for this, we have -4, 0. And so this is saying that I have a coordinate at -4 as well as a y of 0. So if I sketch a graph out real quick, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. This is x and this is y. And the only real hint that I have for you that this one is y, other than normally it's labeled, is that in order to draw a y, you actually have to go down. So think of this part as a downwards arrow saying like this is my up and down. So for the coordinate -4, 0, I'm going to go on my x to -4. So if I just had a line here that was x and this is 0, where would I find -4? Well, I would go this way, 4. So 1, 2, 3, 4. So up here, 1, 2, 3, 4. And so that's the beginning of my coordinate. The next part of the coordinate is to look at this back number. Because it is 0, I don't need to go up or down on my y. Think of it as y, here's a 0, 1, 2, 3, 4, 1, 2, 3, 4. If I have a y coordinate of 0, I'm just going to stay right here. And so if we mix both of these, if we put together these two graphs, we get the first coordinate at -4, so left 4, and then stay at 0. And so for this, you would just you put a dot here, and then you're going to click and you're going to drag it over and hit this -4, and that one will be done. So if we look at that, yep, and we have a coordinate here at -4, 0. And then it wants you to identify the coordinates of A on this graph. And so again, we're always going to start with our x and y. So for us, create another little part here. We're going to count over, and then we're going to count up and down. So for over, if I look, my A is over here, so I'm going to go over. Here's -5, -6, and that's on that line that this point A falls on. And so for my first coordinate, I'm going to say it's -6, comma, and then I need to tell me how far up or down I've moved. So for us, we go from -6, and then we start counting. 1, 2, 3, 4, 5. So we went up 5, and since we went up 5, it's going to be a +5. And so our coordinate is now -6, 5. So -6 and 5, which is the coordinate that we have. Here we go. And this one is just asking us to graph 2 coordinates. So I don't quite remember how exactly they move through those, but for us, what we're going to do is again take that exact same approach of finding these coordinates. And so we have the coordinate A, which is at -1, -4, and the coordinate B, which is at -7, 3. So at A, I need -1, -4. So again, this is an x followed by a y. And so this is my x, so I'm going to go left 1 to right here, but I'm not going to put my dot here Instead, I'm going to go down 4. So I'm going to left 1 and then down 4. So A is going to appear right here. So you'd click, drag it over to here, and this would be your A. For B at negative 7, 3, again, this is my x coordinate first, so I'm going to move 7 to the left. So here's negative 5, negative 6, negative 7, and then it's a positive 3. So this time I'm going to go up 1, 2, 3. So I should have a point here and one, I think it was right here, which is what I have. Negative 1, negative 4, negative 7, positive 3, A and B. The second part of this is to identify the coordinates of A and B on this graph. And again, we're going to ignore this work that we've already done, and we're going to do this for step 2. And so we're going to look at A first, and this time A has us moving to the right, so a positive x value of 1, 2, 3. So we're going to have my A value at 3, and then I move down to get to the y coordinate of A. So negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. So 3, negative 6. For B, again, we're always going to look at our x first and then our y, so our left and right, then our up and down. So for our x, we're going to go negative 5, negative 6. And then our B coordinate y, our y coordinate of B is 1, 2, 3. There you go. And then they just keep adding more. So again, 3, negative 1. My x is 3, my y is negative 1. So 3, negative 1 means right 3 and down 1. So right 1, 2, 3 and down 1. So you should have a coordinate here. B is 6, 5. And so for us, that's going to be right 6, up 5. And then C, negative 6, negative 4 is actually going to be left 6 and down 4. So left 6, down 4. That's C down here. B is right 6 and up 5. So right here. And A is right 3 and down 1. So if we look at that, that's what we get. C, right 6, down 4, or left 6, down 4. A, right 3, down 1. B, right 6, up 5. And again, it's just going to ask you, name the coordinates. So for us, for A, I'm going to have to scoot 1, 2, 3 to the right and down 1, 2, 3, 4. So A is 3, negative 4. Right, 1, 2, 3, down 1, 2, 3, 4. B is going to be an interesting one because it sits right here. So I had to move negative 5. And then I didn't move up or down. So my y is 0. For C, we're going to move right 1 and up 5. Coordinates are always listed as your x movement and then your y. Let's see. Okay, so those are done. And now we're looking at this. So let's get rid of all of this. That was close. Got most of it. That, boom, boom, and boom. Okay. For this one, we're going to start off with, determine the missing coordinate of the order pair 1 something so that it will satisfy the given equation. The given equation is up here at 2x minus 4y equals 6. And they want us to figure out what the y coordinate is with 1 something. So again, we're going to start off by labeling. We know that this is an x and this is a y. So I'm going to take this information and throw it into this equation. So 2 times my x value, which is 1, so 2 times 1, minus 4 times y, but I don't know what y is, so we're going to leave it as y equals 6. From here, start solving it. So 2 times 1 is just a fancy way to say 2 minus 4y equals 6. From here, we need to start solving it again. So I need to get this y completely by itself. And again, I can't touch any of this, which means I need to deal with this 2. How do I deal with this 2? Well, I'm going to subtract it because this 2 is not directly touching this 4y. There's a little minus sign right there. So I'm going to do the opposite of whatever type of 2 this is. This is technically a positive 2. So we are going to subtract 2 from both sides. Those get yeeted, leaving us with a negative 4y equals 6 minus 2. 6 minus 2 is just a fancy way to say 4. And then now we need to solve it one final time. I need to get this y completely by itself. So what's the relationship between a negative 4 and this y? Well, technically right now they are being multiplied because they are right next to one another. Because they're right next to one another and they're being multiplied, we got to break that. So we're going to do the opposite. We're going to divide by negative 4. Whenever we do that, y equals 4 divided by negative 4, which is negative 1. And so for here, you just type in negative 1, which is the correct answer. Step 2. Again, we're going to use this exact same equation, except instead of 1 for the x, we know something else. Let's get rid of all of this slowly. There we go. There it is. All right. So we know that there's given us the second time through is that we actually don't know x, but we do know that y is 5. So we're going to start off plugging in what we know. 2, and we actually don't know x, so we're going to leave it as x minus 4 times, this time we know y is 5, so I'm going to write 5 equals 6. And again, we're just going to start solving this. So this 2x just comes down because there's nothing going on with it. Here, it's not 4 times 5. This negative is attached, so it's negative 4 times 5. Negative 4 times 5 is a negative 20 equals 6. Again, I need to get this 2x by itself, so I'm going to put a box around it to make sure I don't touch it, leaving me with this minus 20. So how do I get rid of this minus 20? Well, the opposite of a minus 20 is in a positive 20, to add 20. So those disappear. 2x equals 26. And then we're just finishing this up. So how do I get rid of this 2? Well, again, it's being multiplied, so we're going to divide by 2. X equals 13. So 13. See if there's another one that's a little bit crazier. Again, on these, there's that. For this, consider the equation in the following ordered pairs. Y equals 4x plus 5. Compute the x and y, so each will satisfy the equation. Again, this is just in a table form. So this time you're going to plug in a negative 2 in for x, and you'll get y. The second time through, you'll put a 1 in for y and try to solve for x. And if you need me to go through that, I can. It again, though, is just more of this. It's just in a different form. And then you're just going to plot those points. And again, you just take it and you just move the dot where you need it. Call it good. Another table, another plot, and there you go. Let's see if there's more. Yeah, there is. All right, it's getting a lot. This looks crazy. It is, again, the exact same stuff that you did right above it. So let's just make this a little less ridiculous. There we go. No. This, again, you are doing all of this work, and you're just seeing, does it satisfy the given equation? So let's actually take a look at that one. And get rid of all this. Probably could have just scooted down. It would have been faster. Here we are. All right. So they give us an initial equation of 4x plus y equals 1. And they want us to test, does the ordered pair -1, 5 work? So in order to do that, we are just going to take this information, plug it into this equation, and see what pops out. So for us, 4 times my x value is -1, plus y is 5, and I'm going to just throw this in parentheses for right now. Whenever you're substituting something into a set of parentheses, or substituting a number in for a letter, I highly suggest you throw it in parentheses. It might not remain there, but it's always a good way to keep track of what was a variable and now is a number. So from here, we're going to distribute 4 times -1 is just -4, plus, if I look at this 5, there's no negative sign out in front, there's no exponent on it. I actually don't need these parentheses surrounding this 5, so I'm going to say plus 5 equals 1. We're going to actually do this. -4 plus 5 is 1, and so does 1 equal 1? Yes, so you would mark yes. Whenever you go down here, you got 1, -3, so again, you'll throw this all in and see yes or no. Does it work? A no is pretty easy to, there we go. No is pretty easy to tell whether or not it works. So we're going to do the bottom of this one just so that you can kind of see what it actually looks like. Again, right, perfect. So the equation we have, 6x plus 2y needs to equal 6, and we want 2.1 and 1. Okay, so again, just plug this into the equation and see what happens. So we have 6 times 2.1 plus 2 times 1 somehow needs to equal 6. So if we take 6 times 2.1, we get calculator. I have an idea of what it is, but let's not take a guess. 6 times 2.1 equals 12.6. Plus 2 times 1 is 2, needs to equal 6. If I add these together, I get 14.6 equals 6. And does 14.6 mean the same thing as a 6? No. And so our answer here would be no. So there's that one.